So, good morning, students. And today we'll be seeing about some of the examples in your Z transform. Okay, so in last class we have seen about the properties. Okay, so we have covered the properties related to your Z transform. Okay, these are some of the properties. One is your time reversal property, convolution property, initial value theorem, final value theorem. Okay, so following by linearity. Okay, followed by time shifting property, modulation, the differentiation in Z domain, then conjugate properties. So these are the things we have covered in the last class regarding the properties. So in this class, today we will be covering with respect to your example problem. Okay. So we have been moving around example 5. So now we'll be coming to the example 6. So here example 6, what they have asking to find is that. So the first thing is given. So given they have given x of n equal to minus a of n q of minus n minus 1. Okay. So here it is a constant. So here this signal we can take it out. Okay, this signal we can find out the range. But over here it is a constant. So you have to know the nature of this constant. So the nature of the constant here they are given us a greater than 0. So a greater than 0 to find z transform. Find z transform. Solution. So first thing is that write the signal x of n equal to minus a of n q of minus n minus 1. So next you write the z transform formula. X of z is equal to summation n equal to minus infinity to infinity x of n z power minus n. Okay. Now what you have to put? You have to put your thing, that is the signal over here. So putting the signal means we getting summation n equal to minus infinity to infinity minus a power n q of minus n minus 1 minus n minus 1. Okay. So next is that you already know that it is here into z power entire, the entire thing into z power minus n. Okay. So what happened is that uh, here your u is given us, that is u of minus is there, so take it common, so n plus 1. Okay. Okay. So now this value will be equal to 0. Okay. When it will be equal to 0, substitute is equal to 0. When it will be equal to 0 means you know already the thing u of n equal to it is a unit value, so it will be taking the value of 1. Okay. It will be taking the value of 1. So when it takes the value of 1 for its real value, for n greater than 1, it takes the value of 1. So you can consider this to be 1. Okay. So I'm just recalling the thing. So summation n equal to minus infinity to infinity. So here you will be getting a power minus a power n into 1 into z power minus n. Okay. Okay. So the formula for this is that. Okay. So here it is negative. So what you can say is that here there is a power minus n is there. You can just either multiply and you can take this n common out. Okay. So if you're saying, if you're doing like that, means you'll be getting summation n equal to 1 to infinity. You'll be getting a power minus 1. Okay. A power minus 1. Then z will be the whole power n. So here what we are doing is that this negative sign is omitted. So we will be taking the minus 1 and this n will be taking out the positive and this summation is inverted. Okay, so here it is the negative value, this negative value will be inverted. So it will be coming like this. So the value of this, what we can take it as x of z will be getting like this. Z, that is a power minus 1 by 1 minus a power minus 1 is that. We will be getting the formula. We are taking the reciprocal means we will be taking z by z minus a. Okay. And your ROC will be z less than a. Okay. So next example 7. Okay. So a given y of n equal to x of n plus y of n minus 1. Okay. Y of n minus 1 to find okay, h of z. H of z is nothing but the transfer function. They are asked to find the transfer function. So in your control system, you have to do the transfer function. The transfer function is nothing but the h of z is nothing but the output by input. Okay, you have to find this value. Okay, so now y of n they have given. You just write in terms of your z transform. It will be y of z equal to x of z. Okay, plus yeah, there's n minus 1. So z inverse will be coming out. Y of z. Okay, now bring this, keep the input on one side, bring the other part. We'll be getting y of z to 1 minus z power minus 1. So y of z by x of z equal to 1 by 1 minus z power minus 1. So this we can again take the reciprocal. So we'll be getting z by z minus 1. So this is what your h of z is. Moving on. Example 8. Given given y of n equal to x of n plus 2 into x of n minus 1 minus 4x into n minus 2 plus x into n minus 3. Okay, has to find system function system function is nothing but the transfer function. System function also refers to as transfer function. Okay. Or impulse response or the impulse function also you have to find. So the solution is take the z transform, take z to 1. What do you get? Y of z equal to x of z plus 2 into z power minus 1, x of z minus 4 into z power minus 2, x of z plus z power minus 3 into x of z. So group it out. So if you're grouping out, then h of z will be equal to y of z by x of z. Grouping out, we'll be getting like this. Plus 2 is z power minus 1. Okay. Okay. Minus 4 is z power minus 2 plus 3 is z power minus 3. Okay. So from this, you have to find, they're saying h of 0, h of 1, okay, h of 2, and h of 3. So what are these things? These are nothing but the sample. Okay. So h of z is equal to h of 0 into z power 0 plus h of 1 into z power minus 1 plus h of 2 z power minus 2 plus h of 3 into z power minus 3. Okay. So if you're comparing now those two things, you'll be getting h of 0 equal to 1, h of 1 equal to 2, h of 2 equal to minus 4, h of 3 equal to 1. So your h of n is 1 comma 2 comma minus 4 comma 1. Okay. So this is what your h. Similar to this thing, you can go with other problem. So it will be example 9. Okay, example 9. Given y of n minus y of n minus 1 plus 3 by 16 y of n minus 2 equal to x of n minus 1 by 2 x of n minus 1. Okay, minus 1. To find impulse response followed by frequency response followed by magnitude response followed by phase response of second order system. Solution. To take the Z transform directly, Writing z transforming y of z minus z minus 1. Okay. Y of z plus 3 by 16 z power minus 2. Okay. Z power minus 2 into y of z. Y of z will be equal to x of z my minus minus 1 by 2 z power minus 1 into x of z. Okay. Now group it out. So y of z will be equal into 1 minus z power minus 1, okay, plus 3 by 16 z power minus 2, okay, will be equal to x of z into 1 minus 1 by 2 into z power minus 1. Okay. Now next what we have to do, we have to bring it on one side to get the response or the transfer function. So y of z by x of z equal to h of z will be equal to 1 minus 1 by 2 z power minus 1 divided by 1 minus z power minus 1 plus 3 by 16 z power minus 2. So now multiply with z, we will be getting az minus, yeah, multiplying by z means you will be getting z minus 1 by 2 divided by z square minus z plus 3 by 16. Multiply by z square. So multiply by z square. So here one z will be there. So multiplying by z square. So what happens? This is that you can take it out with this side. So otherwise, you can also have within inside itself. Okay? It is also possible. And keeping inside means it may have. Okay, you just have like this z into z minus 1 by 2 by z square minus z plus 3 by 16. So here, what you have to do is you have to use partial fraction. Use partial fraction to to separate this z term. Okay. So by separating means you'll be getting h of z equal to. So this is how to use partial fraction. You already know in max. So if possible, in another sum, I will be clearly explaining by step. Okay. So this is easy only. You have to know the formula. So you have to take this as z by z square minus z plus 3 by 16, and this you will be taking z minus 1 by 2 by z square plus minus z plus 3 by 16. So we will be having a b terms. We have to find the a and b terms. So like that will be coming. So I'll be explaining about you in the next problem. So you will be getting like this. So now what you have to do, you have to take the inverse z. Take inverse Z transform, we will be getting h of n equal to 1 by 2 into 3 by 4 the whole power n u of n plus 1 by 2 1 by 4 the whole power n into u of n. So this is your, you can say, impulse response. Okay. So for frequency response, what you have to do? You have to convert it in your j omega term. Okay. That is the thing what you have got in the h of z is that is h of z is equal to y of z by x of z you might have got. So this z replaced by, for your frequency response, so this is replaced by e power j omega. We'll be getting h e power j omega equal to y of e power j omega by x of e power j omega. We'll be getting 1 minus 1 by 2 e power j omega minus j omega by 1 minus e power minus j omega plus 3 by 16 e power minus 2j omega. So this is what your frequency response is. Okay. We're dealing with another one problem. Given, it is example number 10. Example 10. Given input z transform. Okay, x of z they have given, so z by 3z square minus 4z plus 1. Okay, so ROC is, they are given greater than z greater than 1 they have given. This we can, how we can find? Can they what do you say? You have to separate this one, okay, in terms of two terms, and you have to find the pole. Okay, or you have to factorize these things, and you can find the poles. Okay, after finding the poles, you can get this ROC. Okay. So to find inverse Z transform, okay, the solution. So write the signal x of z equal to z by 3z square minus 4z plus 1. So now what you have to do? You have to check with this. I said no, you have to factorize this. Factorizing will be getting z by 3z minus 3. Okay. The next 3z minus 1. Okay. So now what you have to do? You have to find the function. So f of z. So bring this z to that side. Okay. Here f of z be equal to x of z by z. Okay. So will be equal to 1 by 3 into z minus 1 into z minus 1 by 3. So now we have to take pi. We'll take partial integration. We'll be having a by a1 by z minus 1 plus a2 by z minus 1 by 3. Okay. How we can find a1? a1, we take it out. The f of z minus 1 z equal to 1 over there, what will be getting? We'll be getting for a value 1 by 3 z minus 1 by 3 z equal to 1. We'll be getting 1 by 3 into 2 by 3, which is nothing but 1 by 2. Similarly, a2 you have to find a2 f of z minus 1 by 3 z equal to 1 by 3 equal to 1 by 3 z minus 1 z equal to 1. Here 1 by 3, right? Yeah, that is you have to cross multiply like that. Okay, you will be getting minus 1 by 2. So your x of z by z equal to 1 by 2 to 1 by z minus 1 minus 1 by 2 into 1 by z minus 1 by 3. Okay, so now we have to, they have given the ROC. So we have to match with the ROC. We have to match the signal with ROC. For ROC, is it greater than 1? We'll be getting the thing is the x of n equal to 1 by 2 1 of n u of n minus 1 by 2. That is that we are taking the inverse is the transform. Okay, so this is what the regarding today's example. Okay, to see through the problems. Okay. Next lecture we'll be seeing some more problems. Okay, with respect to this, thank you. Okay, we'll be signing off.